Hey everyone, it's Mrs. Olson for Algebra 2. This is your Lesson 7 for Unit 2, Solving Absolute Value Inequalities. Little review here. If you're graphing inequalities on the number line, an open circle is used. If you're doing less than or greater than symbols, a closed or a shaded circle is used if you're doing less than or equal to or greater than or equal to. All right, so let's do 1a here. Let's put this on a number line. X is greater than 4. The way that I do that, I almost always put a 0 on there. For some context, 4 would be to the right. It's not going to be shaded. It's going to be open. And greater than would be to the right. So you got to account for whether or not it's shaded and then which direction it goes. Just a review. All right, now how do we do this with absolute value? What numbers can we plug in for x here and it's going to be more than 4? Well, obviously 5 would make it more than 4, and 6 and 7, but negative 5 also works. Remember, you're going to be taking the absolute value of it. After you take the absolute value, it's going to become positive 5. So let's think about that. We know that the number 4 would be over to the right, and we know that number 5 would work, number 6 would work, and so on. But we also said that negative 5 would work over here. So here's what happens. When you have the absolute value, you're going to have two problems. Not one, but two. You're going to split it up into two different problems. First one, you're going to keep exactly how it looks. Just drop the absolute value. X is greater than 4. The other problem you write, you want to switch the sign, switch the direction of the sign, and then make the number negative, or the opposite of what it was. So that is your answer. X is greater than 4, which would be over here on my right side, and then shading to the right, x is greater than 4, and then x is less than negative 4. That would be over here and shaded to the left. So this is your solution. Now, you can have a number over here or a number over here. You can't have a number on both sides. That wouldn't make sense. So we add the word or to our answer. X is greater than or equal to 4, or it's less than negative 4. Did I say greater than or equal? X is greater than 4, or less is less than negative 4. It can't be both, so we use the word or. For this one, again, absolute value, so you're going to rewrite it into two problems. You're going to keep it just like it is, but just drop the absolute value. And then you're going to rewrite it, switch the direction of the sign, and take the opposite value, make it negative 4. When I put this on the number line, let's start with the x is less than or equal to 4. That's here, shaded in. We would shade to the left. The x is greater than negative 4 would be on the left side, and that would be shaded to the right. So what values of x can I plug in, and I'm going to get less than or equal to 4? All of these numbers in here, not beyond, not those aren't going to work. Only the numbers that are in between negative 4 and 4 will make this true. So this is an and situation. Our numbers have to be less than 4 or equal to 4 and greater than or equal to negative 4. It has to be between these two values. Another way you can write that is with the x in between. Put the smaller number on the left. X is greater than or equal to negative 4 and less than or equal to 4. X is between those two values. Okay, another reminder here. Multiplying or dividing by a negative number, when you're doing inequalities, you're going to switch the sign. Remember, switch, oops, let's spell that correctly. One more time. Switch the inequality sign. So you switch the direction anytime you multiply or divide by a negative number. So going back to what we saw up here, A greater than symbol was an or situation. A less than or equal to symbol was an and situation, assuming that your absolute value is on the left. So this one down here, when I do 2b, is going to be an and the one over here, 2a, is going to be an or. It's a greater than symbol. So this is going to be an or. Let's do this problem right here, 2a. Again, take away the absolute value sign and rewrite it just like you see it. Then write it again. Switch the direction of the sign, make it negative. And now you're going to solve these like normal inequalities. Subtract 5 from both sides. I'm just going to do this quickly here so you can follow. Divide by 4. So x is greater than or equal to. Again, subtract 5 here. Now I'm going to have negative 18. Divide by 4. When you divide by 4, that would be the same thing as negative 9/2, which would be the same thing as negative 4.5. On my number line, I've got a 2 and a negative 4.5. X is greater than or equal to 2, so that would be going that direction. And x is less than or equal to negative 5. So here are our two solutions. And we would write an or in the middle of that, like this. X is greater than or equal to 2, or x is less than or equal to negative 4.5. There's our final answer. All right, for the other one, like I said, this is going to be an and situation. When it's pointing to the inequality, that's an and. Rewrite the whole thing just like you see it, except without the absolute value. Here we go again. Change the sign, make it negative. I'm going to quickly go through this. Subtract 6 from both sides. Divide by negative. Oh, remember, divide by a negative. Switch the direction of the sign. All right, subtract 6. I'm going to get negative 15. Divide by negative 3, switch the sign, and that's going to become positive 5. Put it on the number line, got negative 1 and a 5. So this was x is greater than negative 1. Oops, not a note. I've got open circle, there we go. And x is less than 5 this way. So it's everything in between. That's an and. X is greater than negative 1, and it also has to be at the same time less than 5. You can't really have 1 just greater than negative 1 because that would be over here. Can't have just less than 5. That would also be over here. It has to be both of these restrictions. It has to be both greater than negative 1 and less than 5. It's got to be in between. Again, you can write this as x like this in between the negative 1 and the 5. X is between negative 1 and 5. So it's a second way to write the solution. All right, last example here. Now, I could show you all the work to this, but I am not going to do that. We're just going to kind of talk it out and think about it. What value can I plug in here and end up with a value greater than negative 13? Because you're taking the absolute value, no matter what, you are going to get greater than negative 13, right? No matter what. So this is all real numbers. X is the set of real numbers for this answer. No matter what you plug in there, because you're taking the absolute value, it's going to become a positive number and therefore will be greater than negative 13. Example, oops, I should have changed this to a B. There we go. What value can I plug in for x and get less than negative 13? If we're taking the absolute value, it's not going to be possible to ever get less than negative 13. So this one is no solution. There is no number I can plug into that problem, and we're going to get negative 13, less than negative 13, after we take the absolute value.